will start from. So we have covered data transfer instruction, and we have covered arithmetic instruction, and we have covered logical instructions also. So today we will go ahead and discuss the branching instruction. What are branching instructions? The branching instructions are nothing but they change the sequence of the program. For example, if in C you must have C commands like break, right? Some functions which go to the some other location instead of sequential. So these are nothing but these change the sequence of the program, okay? Based on some conditions. Based on some conditions like if and else. So here also based on some condition, the sequence of the program may get changed. Okay? Or the sequence of the program does not change on some condition, it changes otherwise. So this is same again registers or the registers that we will see. Okay. So coming to first slide, that is branching instructions. What are branching instructions? Okay. So the first thing is that these instructions allows you to change the sequence of the program. Okay. For example, in 8085, what we are doing is we are writing this program in a digital format. So for example, I'm at address 004 times 0, 4 times 0. So the next address will be 3 times 01, then 3 times 02, then 3 times 03, then 3 times 04, and so on. Okay, so the program goes sequentially. So what this branching instruction does is it it may happen that after, let us suppose, some instruction, there will be some instruction, let us say B. I'm not writing the full, assume that all are 00. So it may happen that after this B, the program again moves to some other location like this. For example, after this, the location again goes to 3 times 03. So this is nothing but this is called branching instruction. So it is changing the sequence. From here, sequence is again changed to this place. So if it reaches here, again the program counter will increment all those things, and again it will be executed again. Okay. Again, let us say it transfers from here to here. So again, this condition will be, this instruction will be executed again and again. So it is nothing but it is kind of, this example is nothing but it is a kind of, you can understand it is called iteration. This is nothing but you can say it's a kind of iteration. This particular thing, not all the branching operations are iterations, but this operation can be called as a iteration. 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, and like this. Alright. So the sequence can be changed based on some condition. This is what I'm talking about. Some condition, or it can be changed unconditionally. Okay. So the sequence can be based on some condition, or there may not be any condition at all. Branching instruct the microprocessor to go to a different memory location instead of sequentially. This is what I said. That instead of going sequentially, branching instruct the microprocessor not go in a sequential manner, but to change the execution of the program. That means it brings the address to a different address instead of going sequential. Now, what are the three branch instructions that we have? Is basically these three. That is called jump instruction in 8085, jump instruction, call and return instruction. This will be discussed in detail when we will see stack and subroutine. We will see this in more detail when we see this in stack. stack and stack and subroutine. Stack and subroutine. This we will discuss later. This is the subroutine. Subroutine. And the last one is restart instruction. And this is a we have to deal with this thing when we study interrupt. When we study interrupt, because this are related with these restart instructions are related with interrupt. Again, the head it can be external or internal. So let us see the first thing. What is the first thing? The first is jump unconditional. This instruction is called jump unconditionally. Jump operand is 16. What is this operand? This operand is 16. This is the opcode. This is a 16-bit operand. Basically, this is the address. And address, you know, is always 16. This is nothing, but this is address. Okay. That's why it is 3 bytes. One byte will be for opcode. 2 bytes will be for operand. That is 16-bit address. All right. What the description says? The program sequence is transferred to the memory location specified by the 16-bit address. This is a 3-byte instruction. The second byte specifies the lower order that we will see, and the third byte specifies the higher order. So here they have given an example like the memory address is 2000, 2001, 2002, and if I load C3, C3 is the code of jump, X code of jump, and 2050. So 5020. So what will happen after this? What is going to happen after 2002? The program execution will jump to the address specified by this one. So it will jump to 2050. The instructions in between 2002 to 2050 will not be executed. So that is the meaning. And always remember that whenever you enter a 16-bit address, the lower order will, that we will see practically today, lower order byte will come first, then it is followed by higher order byte. Consider an example. I am writing this, I am specifically writing in a specified fashion. Okay, this is how you have to write the program. All right, because all the program is stored in some kind of memory address. Okay, this is the actual way of writing. This is the actual way of writing, and this is simply I have written that is nothing for mnemonic. But this is called mnemonic. That means it is a shorter format of simplifying writing the microprocessor. But how you have to indent the machine input has to be like this. You have to learn. This is very important. Okay. Because it makes the other person understand what you have written, what is the sequence of the program, how the program is getting in. So this program is nothing but it is creating a kind of sequence. All right, it is creating a kind of sequence of 2 to the power. For example, 2 to the power 0, then 2 to the power 1, then 2 to the power 0, and it is storing in 2 to the power 2 and 2 to the power 3 like this. Okay. So basically this can go infinite times. So what I have done is whenever there will be when this number executes, when this number is greater than 256, it is greater than 256. At the end of the lecture, we will see this practically. So when it is greater than, not greater than actually, when it becomes greater than 255, it becomes 256. So what will happen? There will be a carry generated, and because of that carry, the program will stop there. It will be in hard disk. This is what I have written. And these values will be stored in memory location 4 times 0, 0. Alright, 4 times 0, 0. That is this one. Now let us see what program actually says. So what I'm doing is, because 2 to the power 0 is 1, so I have loaded 1 in A. Alright, I have loaded 1 in